Okay, welcome to part 2 here for Virtualization Chapter 7. So let's strip this down a little bit and kind of think about really what's kind of going on. On the left side here we've got kind of the host version of things. So this is no different than any operating system you've seen running, what you're using on a Windows or Mac or Linux kind of laptop, desktop, whatever it may be. And we've got all the kind of pieces that go into this. So I've got, my capability of having, it's kind of weird to see here, but it kind of pushes it up. So user mode. So I've got my processes. So me recording this video, or my Chrome browser showing you this presentation, or my printer driver running in the background. I have my virtual machines. So I might have, Ubuntu, CentOS, and Windows. All of these, when they actually do something like a system call like write, are going to skip between user and kernel mode. So it's kind of this dash black, or the black line here that's kind of pushed around. When the write is called, it goes down to the actual file system and goes to the right disk. And it's kind of a weird way to show it here, but is what it is. And so this is kind of looking at this virtual machine running. Now, assuming that this is this virtual machine up here, you can kind of paste this, virtual machine in kernel mode kind of up in here now and split this in half in a way. And know that when this, call is made, especially if I want to do a write or whatever, it's going to kind of follow through here to go from, and you're not seeing it here, but let's say user on the top to kernel. That kernel is still in user mode because it's just a process, and that goes down and calls write and blah, blah, blah. Now, another example is, when we kind of think about this from a, other form of how it's gathering resource. This is doing, I/O, whether it's disk or, let's just say disk or network, just to make it simple. I also might want to get down into trying to understand how am I going to get memory, or how am I going to get other forms of resource. And it's just going to be a kind of a different way to kind of deal with it. So maybe it's that in doing all that, I need an interrupt handler to go ask for some I/O, like this SCSI drive. Maybe I'm also asking for memory. Maybe I'm asking for just CPU time. And how does all that work? So this is an example of how, as this kind of flows through, I have to kind of promote myself as another thing that the kernel's managing, but through a different kind of driver. Because again, especially in x86, I was never defined to do this, and it doesn't make sense for me to do this. So not only am I loading virtual machine software, but I'm loading these drivers. Now I keep referring to this toolbox, and the toolbox, as it kind of comes in different flavors and shapes, and is used by different guest and host OSs in different ways. You will physically see it as something more of a way to map file systems and make things easier for you as a user. But I know that it's also some ways to optimize how this entire transaction works. We can think of how memory is allocated and used in the same kind of fashion, where on the top we're dealing with just kind of our normal ways of dealing with virtualized space. So I got my process A, B here, but then when I get into the virtualized piece of it, I might need some for the host OS, or I'm sorry, the guest OS itself. And then how do I manage all of my resource? I may need special space to do that as well. So that's why you see this virtual machine user space, much like you would other spaces here, that goes to kernel. But if you put these two together, they end up only being one of these on the left hand side, an A or B type of user space for the actual host. Another way to think about it and look at it, so architecture, so the physical things that are being laid out, CPU, RAM, all the I/O stuff. ESX hypervisor is an operating system. So its only lot in life is to support how we leverage different forms of virtualized guests, and we normalize them so that they can be used quote unquote all at the same time in a fair way. And again, I'm going to keep harping on this because I think it's important to note that the type 2s are not necessarily optimized to be fair across everybody all the time, mainly in the fact that we're using OSs that were never meant to be virtualized. So I'm not, this is type 1, so in type 2 I'm using my native Mac, but I as a human am only really doing one thing at a time. Now of course I could start up some big job and I could have a server running on one and deal with the other, but it's not really optimized to be the most efficient and run that way. So type 1s are defined that you're not going to be on this hypervisor. You're not going to log into it. You're not going to write code on it. You're not going to run web servers and browsers and everything on it. Its job in life is only to support the guests. So it has to do that in how it deals with resource. And so whether it's a CPU scheduler, and like I said before, there's that long and short term. This is more, how do I make it fair across all of these things? So when I think of, like in Linux today, we use completely fair as the algorithm. What is the algorithm for hypervisors themselves? Can I simply say that I'm dealing with an OS by itself? So if I look back at this example, I just round robin and say you get some CPU, then you, then you, then you? Or is it that I have to say you've been using a ton, so I'm going to give you 80% and then 10, 5, and 5? No, we wouldn't do that because we never look and manage and measure to that level. Or do I just have to have an algorithm to say, look, I know that all these are probably going to be used pretty equivalently, and I might just say, okay, I'm going to ask you, if you don't need it, I'm just going to go on to the next one. But if I do give it to you, I only give it to you for a certain amount of time, but it's not going to be like the 200 quantum like we do in completely fair. It might be some longer time or some arbitrary time. We don't really ever get to adaptive or change it around. It's usually fairly fixed. But again, that hypervisor's job is to do that. The memory manager, knowing that there is only one physical MMU, how do we leverage all that RAM through that, knowing that each guest OS doesn't know that it isn't the only thing controlling that. So we need something in between there to really kind of be that, and that's really one of the roles of type 1 hypervisor. The I/O subsystem, again, what we're doing basically is we're adding more queues, more caches, more ways to buffer all these requests instead of it all just kind of falling into one, because we can't necessarily identify, prioritize, or get to some interesting algorithm outside of round robin, first in, first out, which from an I/O perspective might not be the easiest and best. So how do we deal with that? So on and so forth. So one thing I did want to run through is kind of showing you what this looks like in both a type 2 and an Amazon world. So I've been kind of showing you this throughout the semester, and when I look at, let me try to pull this into focus here. As an example, this is Parallels, and this is my type 2 hypervisor running on my Mac OS. And so you see different versions of OSs here. So I've got Android. Mainly I use Ubuntu, so I've got 1804. I think this is 16. Kali is a cool security thing if you ever want to look at it. CentOS and Debian and just different versions. Haiku is an interesting one. I don't know if some of these even work. Haiku used to be a called the BE operating system, BEOS. And you notice it looks fairly similar to some other things. And doesn't really have much to it. But kind of an interesting one if you can get it installed. One thing you do note about Haiku is that it crashes quite often, and that's what it's kind of doing here. So there we go. Get control back. You noticed when I was in here, I don't know if you can see it quick, but well, broke that one pretty good. That one's gone. You know, I could pop into Windows, whatever. The one I did have going, must have shut it down. So, it doesn't really matter. I'll make this Ubuntu work. I'm going to pull it into focus here. So, this would be firing this guy up. And what you'll notice is a few things. This is actually on the top here. This is brought in by the actual Parallels program itself. Up on the top of my screen, which you can't see, is the toolbox. You can see some of it there, I guess, in the window. Let me pull this up a little bit. So up here is the toolbox where I can, you know, kind of do certain things from a management perspective. You know, I can configure things. So this is kind of where all this comes into play. And for this specific Ubuntu, you know, I can set up different forms of hardware. So how many processors, how much memory. Notice this is grayed out because it's started. What is my hard drive? You know, if I want to get, you know, fancy with where some of these things are, it all kind of pulls in there. But because it's running, I can't change that. So I could go in here and do all this back and forth. You know, it's a little laggy, it's a little slow. You can see, you know, network and hard drive and network. Or I'm sorry, network hard drive. This is USB here, maybe. Yeah. So you notice it's taking a little bit to boot up. It'd be much faster if it was native, but you know, because I'm doing this and I'm on this machine, it is going to go consume 2 of my processors, gig of RAM. I can change some of the stuff if I want, but you can't hear it, but my fan's going off. And yeah, this is consuming a lot of power. And I think if I went back out here and I looked at top, you know, I'm running out of memory. And I really don't have much left. So, I don't know why that's taking all of its sweet time, but it does. So that's an example of a type 2 hypervisor. I don't have a type 1 on my machine here because its only job in life is to kick off new things. But the one thing I did want to show you that really isn't in the book, but is going to be more of the mainstay of what you're going to do kind of in life, is around Amazon and what the AWS cloud kind of gives you. Over the years, we've kind of dabbled between Amazon, Rackspace came out. I will talk about OpenStack, which I think is one of the most powerful, cool things out there. Maybe not something you're going to use day in, day out, but something you definitely need to understand what it is, how it works. So I will pause here for a second. I just want to make sure I log into my instance and not waste time here, so I'll be right back. Okay, so before we go into here, the one thing I wanted to kind of talk a little bit about is the fact that Amazon AWS, Amazon Web Services, is really kind of a container, a place that you can go to utilize a lot of compute resource. You would note if you pulled some of these things apart a little bit that a lot of them are Apache projects. Just so we see kind of what I mean by that. If you go to apache.org, which is a container for a lot of open source projects, it has its own license. SourceForge.net is another place to go look at a lot of open source stuff. But if you wanted to go out here and look at kind of what projects are out there, it's quite a few. You would note that this is the mainstay of Apache, which is their web server, which they put up here. But everything from Cassandra, which is a form of distributed database, I want to say time series as well, to Mesos, to some development tools like Maven, Hadoop, which is a distributed file system, there's a lot of stuff out here. So a lot of what you'd see in Amazon, if you really pull the cover off some of these, is, ooh, Tomcat is actually this, and what do they have for, so Lucene is a part of the Elastic Elk stack. Trying to think of the RabbitMQ or ActiveMQ. That's it. So how to do messaging. So there is a lot of this stuff out there, but from a Amazon perspective, EC2 is the compute piece. So Elastic Cloud Compute, sorry, is what that stands for. We'll also see S3, which is what most people think is a hard drive. Absolutely not. S3 is actually object storage. What we use for hard drives is block storage. So you will see the Elastic block storage comes in there. You can create your own virtual private cloud, then create VPNs. You can do identity management, and it goes on and on and on. So to kind of look at this, I'll log into my instance here. And of course, I got to change it. And we go in here. Now, really the big deal is to kind of go in here and look at all the things that you can do. So the most general things, EC2 is going to be here. Elastic Beanstalk, which is Tomcat. So again, if I was to pull the cover off that, I would see that. What are some other easy ones I can pull out here? Databases. I don't remember which one they call Cassandra in here, but that's one of them. Here's where is file systems? So S3 is in here somewhere with a whole bunch of other ones. If you want to do development, there's this whole concept of CodeStar and how you create pipelines, and there's monitoring tools, which are fairly basic, but kind of gets you enough to know if things are running or not. If you wanted, Chime is an example of a kind of a soft phone. Workspaces, if you wanted to get into a little bit more of the idea of having your own desktop kind of office thing with some of the apps that are here. A lot of IoT stuff kind of kicking up because this fits really well in microservices. Still not seeing, storage. So S3 being, again, block storage, I'm sorry, object storage. EFS being more the block storage. Glacier being things that are used kind of backups and offline, so it's a lot cheaper. AWS backup is just the program to actually do that. So let's go in and let's look at an EC2 space here for a second. I don't want this to be a tutorial on Amazon. I just want to kind of point out a few things. One is you need to kind of select where you want to be. So here's all the places that you can, let's just call them data centers. I'm dumbing it down by calling it that, but I do have something on the east, a couple on the east, a couple on the west. Now, physical locations don't really make any difference. It's the milliseconds between, which are, 2 or 3 milliseconds, so nothing to worry about there. But if I was going to go deploy something that was real time, in Hong Kong, I might want to pick this one. One thing that I think is very, very overlooked in this space, and this goes back to what I was talking about before with the whole kind of code monkey kind of thing, is East and West usually wants to be treated as one combined thing for high availability. So we do want to build things that have an East and West component, but it really makes a big difference in how we're leveraging that, because I can't put one operating system across both. Even if I've got one in each, that doesn't mean applications know how to share and jump between the two. So just to note that I am right now in this North Virginia East, and when I look at things here, I see 2 running instances, 12 volumes, 8 key pairs. But if I flip over to even Ohio, things are all different. So, don't get lost in the minutia there. So if I was to look at some of the stuff here, and let's just say that I want to create a new instance. I'm going to pick either my Amazon machine image, an AMI. So these are much like we do with other virtual machines, whether we want to go get a ISO image and load it from scratch, which I don't really suggest doing. There isn't as much value. Or am I going to get a VMDK, which is a virtual machine image. This is just an Amazon image. You notice there's a free tiers for certain sizes. So if I was to go into any of these and pick my, let's just pick a deep learning AMI, which just means it's been loaded with all this software stuff, TensorFlow and all this fun stuff. I'll just create this one because it's free. I can pick architectures if I wanted. I could size it. Notice this is the free one. They kind of give it these sizes, nano to micro, all the way up to extra large. You can just see its number of CPUs, amount of RAM, how it works. So I could go through and I could kind of pick whatever I want, 64. It's kind of fun to fire some of these up and see how fast things run on one compared to the other. But I'm going to go configure this a little bit. So I'm going to go leave it at its network. I can join it with other networks if I want. Trying to think of what would be interesting here. So I'm just going to kind of leave that. Storage usually comes by default, so it's going to give you a fake hard drive. Here's where the snapshot is. Here's what kind of solid state drive, which I think is the cheaper one. Yeah. So 100 IOPS versus 400. Keep it at that. I can encrypt, add, whatever. This is 8 gigs. Again, we're going to treat it like cattle, not like kitty cats, not like pets. 8 gig hard drive is actually pretty small, right? But what are you really doing with it? Are you going to go load all your DVDs on it or whatever? So I'm going to go ahead and launch this one. I already have, oops. I say that, but let me make sure I got it. There it is. Okay. If I don't have this, I'm not ever going to be able to log into it, and how do we even know it works? So I'm firing this up. Now this is, again, radically different than what we would see in dealing with VMware, because in VMware we're actually going to load an operating system, or we might pull one in that's already built, but I wouldn't have all these fancy functions and ways to change things around. I could statically kind of give things, but here I've got this thing being launched. I can look at its status, it's pending, it's initializing. I've already got certain things, attributes around it, so I do have a bunch of, let's say IP addresses as an example. So I've got my private, which is a non-routable 172. I have my public, which is routable, and if anybody's followed along, I think Amazon actually got 6.x.x.x as its next block of addresses, but I don't know, the monitoring turned on, but this thing's already up and running. So I could go give it a name. And away we go. Now, a couple things I could do is, if I wanted to really kind of show that this is running, just want to check a couple things here. That should be fine. And everything's good to go there. Now what I do is I can go here and, what was this, Ubuntu? Yeah, So I could say I gotta add my key pair in here. And now I'm connected. So that is the basics of, and very, very basics of Amazon. Now, the thing is, if I want to, I could create a new instance. I could do a whole bunch of stuff. I've got this one sitting here in this kind of state, but I could manage it in ways too. So I could kind of look at this and say, okay, never shut it off from here, but you know, if I was to go ahead and I don't have any of that turned on, but I could go kind of back and look at this stuff and say, trying to remember how do we shut this down, which I've never done this way, but there we go. Okay. So I'm going to go ahead and stop this. And notice I got bumped out. So that's Amazon, and again, you could take this to all these different services. If I wanted to, I could create new hard drives. You know, if I wanted to go create my own file system, I could pick, you know, kind of where I want it to be. Again, which virtual private cloud I want it in. Share that amongst different things. I could go create new databases. I think I've got choices of Microsoft and Postgres and that. So on and so forth. So you can build, yeah, so I've got Microsoft SQL, my Postgres, all that here. So, so a lot to do here. So again, you definitely have to really know kind of what Amazon's doing, what they're up to. That's kind of a quick tour of that just to see kind of what that looks like. This is a standard, I just want to kind of put this in there, your standard kind of footprint. This is even a little dated, but you know, a region is, you know, going to be east, west, whatever. Here I've got VPCs that puts all of my stuff together, and then I can have two separate subnets and a router, and all of this is virtualized, but how it gets out to the internet, my routing tables, so on and so forth. So tremendous amounts to go into setting all this up, and kind of goes on forever. Another example, and I just want to talk about this again because this is something you guys did in Lab 1, dealt with namespaces, which gets us to containers, which is Docker, which is, you know, this whole microservices kind of concept. And, you know, you did all of these, so you know what mount and net and all that stuff is, you know, using the clone calls. That breeds into this whole kind of concept of Docker, and Docker really is more about the containers on ships. And you know, when you want to ship something, you know, a long distance, it used to be that you would just kind of load things in different storage spaces. But you know, again, think of that fragmentation thing again, that internal and external fragmentation. If I just have space all over the place, how do I know where to pack things, and how do I know whose stuff is what? How do I demark it and secure it, and I mean all these things. So the shipping industry actually came up with this idea of a standard container that fits not only on ships but also on trucks, also on railways. And so the whole concept of Docker kind of came out of that, to say, look, why don't we just have one common thing called a container, and why don't we put what we need to into that container, and then you can call that container my web server or my microservice container or my thing that just does stuff, and whatever it does, it does. Now the containers, there's a little bit of a difference here. The containers are not all specifically exactly one size like is shown on the picture here, but they are purpose built in that they can be reused, and you can have multiple containers all running at the same time. This is a very, very small view of this. Most architectures are built out very advanced with and you can't get away with just a container anymore. You've got to have something that manages the space that containers run in. manages the OSs, which I'll talk about in a second. But we think about these as lightweight microservices because they live for microseconds. A second would be a really long time. Now, these examples here, where if I have a container with Tomcat on it, well, that one's going to live forever. That's really not a microservice. It's kind of more of a macro, or kind of something that would be living. I'm not a big fan of that because that's really not the point of a microservice, because that's technically what an OS is there for and what we want to do. But we kind of take from that and we think about, okay, what's the difference between a container and a virtual machine? We don't have that heavy OS coming with us all the time. We don't have these OSs. Really, we've got this layer of Docker that sits on top of a host OS. What do you think is in Docker? Clone commands. What do clone commands do? They build out these spaces. They build out a separate network, a different, username, different, all the things that you guys have already done. Docker then again turns into Swarm, which is our way to orchestrate and manage it, and then Kubernetes, and I'll talk about some more in a second here. More importantly is for you to look up and understand OpenStack. OpenStack is one of the largest open source things that's ever been created. It's a massive, massive system. OpenStack, if you wanted to run it yourself, is a minimum of, I think, 3 machines. To even do it in a lab perspective, I think I think there's a mode you can actually run on your laptop, but there's not really much point because you don't see what's going on. But the concept is why don't I build a compute farm, a networking farm, and a storage farm, and I just use what I need to when I need to. And that's a much more powerful way to do it than what we talked about before. It removes that fragmentation problem, because now I've got the capability of having stuff when I need it, that elastic thing, and when I don't need it, I just give it back, and then other things can use it. So think about having, a pool of RAM across everything like we do in a single OS, across multiple OSs, across multiple different things. Now, OpenStack is very complicated very quickly, and I want to talk about some of these packages because the packages actually are defining the unit of thing that it does. So like Nova runs all compute, but then there's 10 different ways to do it. Neutron, I think there's 5 different ways to do networking. There's, static tunnels, GRE tunnels. I think there's a couple of virtualized. Swift and object storage is much like Amazon S3. Glance is where we're going to store all of our images if we want to run VMs in there. We don't have to run VMs. We can just run microservices as well. We have Cinder for block storage, so that's going to be where we're going to use, standard hard drives. Keystone is going to be the IAM stuff, identity access management, and various other ones. So this is kind of the stack, and this might even be a little dated here, but Horizon is the front end. I didn't show that before. If we jump down, we've got things that gives us, our networking here, Swift to Cinder that we saw before. What's interesting though is if we think about some of the stuff up in the second blue here, this is microservice based stuff. So microservices cannot just simply be something that's there that we just use like we would call in a C function, because that's really not its intended purpose and not really what it's there to do. It's really there to do work and go away. Now that can't happen without some things to manage it. Orchestration is one thing, and orchestration is really being able to spin things up and spin them down. So how do I make things move up and down, and how do I even know to do that? So does orchestration also have some capabilities of monitoring what event happens to make those things fire up, fire down, versus kind of the workload provisioning, which are things like Magnum as an example, is a way to go really kind of look at I need more microservices to run, and almost from like a CPU scheduler perspective or more of a job scheduler perspective, I need to manage all these things to happen, and I don't really care where they happen or not, but I just want to go to OpenStack and say, hey, I need this right now, and I'm going to run it. When I'm done, I'm done. I move on. I go do something else. What's not being shown here is there's another project that was actually kind of pulled in this whole Magnum piece, which is called Mesos, which is an Apache project. It was one that I showed you earlier, and that one is the ability to kind of run processes, whether they're microservices or just full processes, serverless. So that's one thing I didn't really talk about that kind of fits in this whole kind of model, is this whole serverless concept. And serverless comes in a couple flavors. So Mesos is one of them. If I was to go to Amazon Lambda, if I could find it here quick. Amazon Lambda is the, I'm not finding that, is the serverless way to write code. So you don't have to tell it anything. You don't have to tell it, you said, write code, get it deployed. There it is. So with Lambda as an example, I just got a couple here. So we were messing around with Alexa skills, I guess, a year ago. I can pull in my actual code directly into Lambda and have it run. Now notice I'm just writing code here. I'm kind of pulling it in. This designer really is just to say, okay, what makes this happen? How do I call this? Let's be honest here. Even though I say it's serverless, I could still go down here and give it, concurrency things. I can actually give it the amount of memory and compute I want. So here I can say, let's just start out with so much this, so much timeout. Why am I going to make it run? And I have to be a little more explicit about, which languages I want it to run in. So this was picked specifically as Node.js. If I go create a new one, create function, I have to choose. So these are the languages that are supported. So note, I can't run Perl, I can't run Shell, I can't run C. I'm kind of stuck to, .NET, Go, Java, Python, Ruby, and Node. Some of these others can work, but notice even Python 3.7, 3.6, 2.7, it makes a big difference, kind of what's there. So other forms of that. So as we think about this virtualization, where we've really gotten to is, yes, in mainframes we could carve things up. Then we got to OSs that had different forms of type 1, type 2 hypervisors. The world is now moving to Docker containers through Linux namespace, into orchestration layers, through things like Mesos, to now serverless. And it isn't that you can say, well, why do I even need to know operating systems if all this stuff is still happening at certain levels? We're many, many, many years away from getting away from any form of not needing to know an OS, but the reality is even though I'm creating these serverless functions, they're not going to do a tremendous amount without still a good kind of understanding of what an OS is and can do. Plus, we also still need to obviously know what things I can do in code with an OS if I want to do file I/O and the rest. So with that, I'll leave you on virtualization. Thank you.